was also a part of this group, which is authoring a slope guideline. So the different methods which is mentioned in the slope guideline, one is avoiding or eliminating the problem itself. If a lot of landslide is there, avoid that area. Second is use of lightweight materials. So for a embankment or where we have to do the construction or cutting or filling in a hill road, if we are using the lightweight materials for the embankment, that will be having the minimum tendency to move away. Okay. So use of lightweight material is another method of reducing the issues. Then modification of slope geometry. So mainly is when we are facing the slide problem or slope instability problem because of a steep slope, then modification of that slope geometry, that will be the correct solution. Okay. അപ്പം പുതിയ ഒരു റോഡ് ഉണ്ടാക്കാനോ റെയിൽവേ ലൈൻ ഉണ്ടാക്കാനോ ആയിട്ട് ഇപ്പം നമ്മൾ സിൽവർ ലൈൻ പറയുന്നുണ്ടല്ലേ കേരളത്തില്, കെ ലൈൻ. സോ ഫോർ ദി സിൽവർ ലൈൻ ഒരുപാട് സ്ഥലങ്ങളിൽ നമുക്ക് കട്ട് ചെയ്യേണ്ടി വരും. ഒരുപാട് സ്ഥലങ്ങളിൽ ഫില്ല് ചെയ്യേണ്ടി വരും, ഒരുപാട് സ്ഥലങ്ങളിൽ കട്ട് ചെയ്യേണ്ടി വരും. അതുകൊണ്ടാണ് അതൊരു ഇഷ്യൂ ആണ്. ഒരു ദർ ഈസ് lot of acquiring of land acquiring will be coming, and definitely civil engineering is having its own method. Nobody need to worry about how the structures will be stabilized and protected. So civil engineering can cope with that. But many places there can be social impacts when we are acquiring the land. Somebody's land may be getting modified, so nobody likes to lose their land. But let us come back to our topic. The effective stabilization scheme sometimes consists of some modification of the existing slope geometry. It can be excavation of top of slope or flattening of slope or benching of slope. Benching means providing the benches in between a slope and break a continuous slope into simple small slopes. Then complete removal of unstable mass. Sometimes in a slope, a rock slope, there may be some part may be unstable. So we can remove that. Earth fill at the top of the slope. So that is again another method. Then rock or gravel fill at the top of the slope. So that is again the another way of strengthening. Okay. So the modification of slope geometry, if we are excavating the top of the slope, will it help the slope stability or will it disturb the slope stability? Anyone? It will be increasing the slope stability, the factor of safety, because we are reducing the driving forces. But if we are removing or if we are excavating at the bottom portion of the slope, that will be increasing the destability. Okay. So in the excavation at top of the slope will be favoring higher factor of safety, whereas excavation at the top of the slope, that is endangering the slope stability. Now coming to the drainage solutions. So drainage solutions can be just drainage pipes. What are we seeing here? I'm not sure all of you can see that in a particular slope which is showing a lot of slope instability, just by introducing horizontal pipes and draining out water, that is making the slope stable. Okay. Another method is, this is about the surface drainage using the gabions. I don't know whether you are aware what is gabion. Gabions are rectangular boxes which can be filled with stones, and that can be used as building blocks for different types of retaining walls or protection system. Here such type of boxes are used as chute drain. Okay, what is chute drain? Chute drain is nothing but our normal the drains what we are seeing. Most of it are open drains. Okay. So using gabions, they constructed an open drain, and that is gabion chute. Then cascade drain. Okay, in this case, it is a smooth inclined drain, but in the next case, it is not just an inclined drain. In in the inclined drain itself, there are a number of stops. So, what is the advantage of providing stops? Definitely, there will be the construction cost will be more, but there will be enough dissipation of energy of water. Then there can be other type of drains, but I will call most of the surface drain as just surface drains only. My more interest is here to talk about the subsurface drains, because most of this slope instability problems will be originated by the subsurface flow. But here, through this, a lot of photos, the message which I want to give to all of you is that in hills, when we think about the slope stability, one of the most essential step is to ensure a drainage network which is completely functioning. Because when we are talking about only one uh, side of a retaining wall, or just a drain pipes which is coming out from rocky strata and all, we have to really understand how the subsurface drainage, the entire system can be defined and designed. So why this much importance to the draining? Because the if we take hundreds or two hundreds of landslide cases in our country or even in Kerala, the analysis will finally emphasize one factor. The if we are providing proper drainage, we can avoid the landslide. Most of the time, the drainage can be of surface drainage and subsurface drainage. So you can see a photo here. This is about how the subsurface water is coming out, and you can see that a lot of gabion structures are given around that, so that it will not be having any type of the intervening from the surrounding places, and it can work as a continuous drainage measure and scheme. So surface drainage measures, if we are looking at the most famous or accepted the guideline for the Indian slopes are it is Hill Road Manual, and this Hill Road Manual, it is talking about toe drain, like as the name indicates, below a slope at the toe, if you are providing a drain, it is called a toe drain. Then intercepting drains are the something which is intercepting the design flow. So the intercepting drains are shown in this drainage network. I hope you can see my cursor. So there are main drains, then there can be longitudinal drains. So in the longitudinal drain itself, where it is found suitable, a trench need can be established, and that can be used for as the purpose of the drainage. Now, coming to subsurface drainage measures, there are different types of subsurface drainage measures like horizontal drains, cut-off drains, drainage trenches. So, to make you remember, I will say that, so for all these, the subsurface drains or the one which is going through the strata, first and foremost part is that to understand the seepage path. And this understanding seepage path, there are different types of geophysical methods, or some equivalent methods can be found out, where we can find the path of the seepage path. If it is a rocky strata, we may have to identify the water bearing rocks, and to decide that how the seepage can be channelized so that it will not cause a slope instability. The upper photo what you are seeing, this is actually the rocks which is facing the Mumbai Pune expressway. There a lot of rock falls and slides were happening, and it was found that the seeping water or the subsurface water is the problem. And in appropriate places, with the help of a geologist, the horizontal um, the pipes are uh, inserted, and through this pipe the subsurface flows are happening. The illustration what you are seeing here, that is a reinforced soil structure. What do you mean by reinforced soil structure? Reinforced soil structures are a type of retaining walls which are having geogrids or steel mesh as the main fascia, and the secondary reinforcement will be either it will be connected with the gabion, the gabion's bottom panel is extended to the soil as the secondary reinforcement, or it can be from the green fascia also. The same reinforcement can come as secondary reinforcement. So, but where is the surface or surface drainage or subsurface drainage? So here there is a chimney drain. Okay. So the chimney drain is a vertical drain which is collecting all the water and eliminating it without causing a problem for the reinforced soil structure. Now, how to design the drainage system? Can we just give randomly, or just by doing some assumption? No, it has to be designed basically as per IRC SP 042. If we can design as per IRC SP 42 and then presenting to a client or a consultant, they will be very happy because the code is describing almost everything. So what is the procedure to do a drainage design? First of all, rainfall intensity, we have to collect the details of the rainfall intensity. How can we do that? If we are approaching, say, irrigation departments in local states, you may be able to get the detail of rainfall data. I used to, as I am in Delhi, I used to approach CWC or this type of important people who are working in different parts of the country. Then see, apart from the rainfall data, another point is that how much land is receiving the rainfall. Okay, especially for a slope. If it is a rectangular plot, we can immediately tell that, oh, this is the area where the peak catchment area will be there. But it will be at present in a limited area only. And if the catchment area is also found out, then the next is, after evaluating the infiltration capacity, we may work out the peak runoff, or hydrological study will be conducted. And then as per IRC 82, IRC 42, we can do the hydraulic design. As I mentioned that whenever we give a slide mitigation or a slope instability, we have to connect the different existing drainage. Like there may be existing culverts, there may be some dry rubble work. So instead of telling all these are wrong, the approach from McAfee is that, okay, fine, we have taken the details. If we can bring a better, attractive proposal to you, we will work on it. Now, the basics of flexible systems. I was mentioning a number of times flexible systems, and I have shown in some of the illustrations and some of the photos also. But let us look into a little more close on the different types of flexible system. In the different types of flexible system, maximum at present popular in India is reinforced soil system. So the reinforced soil system, we can see there is a green fascia, and then there is a gabion fascia. Okay, that is fascia only. the one which is giving the strength is the main reinforcement which is going, which is a high strength geogrid, and the secondary reinforcement is going at the middle, which is in fact the also acting as a secondary reinforcement. So now when we are seeing, I don't know whether you all are aware of reinforced soil structures. Reinforced soil structures are when we are placing the reinforcement or tension element or something which can take the tensile forces effectively. That will be placed as reinforcement inside the soil, and there can be different types of fascia, like given fascia up to here, and then a reinforced soil structure. We can see that. Okay, and the upper portion, it is a green fascia, and the lower portion is a Gabin fascia. So what is the Gabin fascia? Gabin fascia I already described. It is a rectangular steel wire mesh box filled with the stones. That is the building block of the the Gabin fascia. What about the green part? This green part, which is marked in yellow, so that will be uh, the fascia. It cannot stand vertically because it is doesn't have something which is making it stand. So it is a woven mesh, which is the same mesh of gabions or matrices, and inside that, a weld mesh will be placed. Why weld mesh? Because the woven mesh will be having a flexibility and it will not retain the shape. If we are placing a welded mesh inside that, then woven mesh can stand. And apart from that, one more material will be added. That is actually coir geotextile. Okay. So our Alleppey is in fact known as a world hub of coir products. And this product definitely it requires a lot of coir, and that can come definitely from Alleppey or maybe from Sri Lanka, and that can be a very good potential for that product. So I mentioned about the reinforced soil structure. So this is a reinforced soil structure with this is the Gabin fascia and this is the structural fill. So for this Gabin fascia, we really have to see that the boulders which are filling in the Gabin fascia, that should be durable, non-friable, and uh, the boulders should be falling in the sizes which is prescribed by the different courts. So the usual sizes for the Gabin fascia which is produced in India is 1.5D to 2.5D. Okay. Now another material, that is filter media. Okay, so geotextile filter media. So whenever we are going for a say given structure or a mattress structure and all, then it will be good to have some geotextile which can act as filter, separator, and even for shore protection application. So we talked about this primary reinforcement and secondary reinforcement in a reinforced soil structure. So I am little skipping there. So we have seen the reinforced soil structure as a retaining wall. Now let us look at slope stabilization using, what is this? We are seeing nail heads. Okay, a nails, and if they want, they can really plant even vegetation there, like in the right side what we are seeing. Okay, so in the left side where we are seeing the a structure which is in Chennai. It is for a real estate company, Sriram Chennai. So the Gabins is sleek only. What you are seeing is not having a lot of base width and all, but each of the Gabins getting connected to the original stratum like this nailings. Okay. Now another case which is down. This is in fact from Kerala Tamil Nadu border. L&T is doing a 90-degree vertical slope, and then they want nailing the fascia, and the fascia should be highly green. So this structure is getting done. It is not completed. Even if you are interested, we can arrange some sort of site visits. Now, coming to simple erosion control, we were talking about reinforced soil structures with the different types of fascias, different types of drainage arrangements and all. But at the same time, the erosion control also important. ശരിക്കും ഈ മിക്കവാറും ഉള്ള ഇങ്ങനെ ലാൻഡ് സ്ലൈഡ് അഫക്റ്റഡ് സ്ട്രെച്ചസിൽ എൻ്റെ ഒബ്സർവേഷൻ എന്താന്ന് പറഞ്ഞാൽ കട്ട് ചെയ്ത സമയത്ത് whenever it got cut, that time itself, if we can do a erosion control, then many of the disastrous landslides can be avoided. But that time we will not be ready for spending that 10 rupee, and it will end up with the instead of 10 rupee it will go to thousands or lakhs. So for example, this is a cut slope. So when you are cutting itself, you know that it has to be protected, otherwise the water will go and it will go inside the soil and create problems. So this is in fact the hillside protection works which for a Sikkim airport project. Okay, so we can see a complete greenery has come. So what is being used is a erosion control mat, like coir mat, with the U pin for making it hugging the earth, and then doing some seeding. It was if it is a difficult place, the steepness is quite high. Not in this case. This case we are seeing it is only 45 degree. But if it is more than 70 degree, the mat which are being used for covering this area, that may get teared off. Okay. So it need to be taken extra measures when the slope is more. There is a table which is given in the highway handbook, MORTH, or the highway engineers will call it as orange book. In the orange book, section 700, I think the table number again 7, it gives the different types of slopes according to the different angle and rainfall intensity. We may have to add with the bioengineering mat, we may have to add a mesh which is having higher tensile strength. Then the last one, which is again the same, I talked about Tamil Nadu Kerala border. There is a slope, and this slope is stabilized with the nails and the front fascia. And why I added this photo, because we can see that the nail points and the plate, as well as the slope is almost vertical, and we can see a engineering mat, not bioengineering mat. It is not coir or jute, but it is a polymeric product, and through that we can make very aesthetically pleasing slope with planting good looking trees. Now, the erosion control mats, that is, in fact, it is not not to be taken as a subject. We all have to speak a lot. But there also some engineering is there, and it is not just what we are learning in school only, which is talking about the topsoil should not be lost, and we can plant trees, and something like the coir log or jute will help to mobilize the vegetation. But apart from that, I talked about there are different types of erosion control mat, and when the steepness of the slope increases, we may have to use a erosion control mat with a higher tensile strength. So the same mat, same polypropylene mat, if we are inserting a higher grid, geogrid, which is having 10 kilonewton per meter or 8 kilonewton per meter, so that will really make the whole entire work to be a performing one, and there will not be any sudden collapse or failure. Now, HECP, this is again a erosion control method, and here it will be sprayed through water. So we call in general hydroseeding. So hydroseeding is an effective method in some places where we are just seeding or we are planting. That may not be enough. In such cases, we may have to go for hydroseeding, especially the slope is quite steep. Now let us move to another type of slope instabilities, which we have seen in the introductory part, that is rockfall mitigation measures. Okay, so rock detachment also can cause a slope instability, and sometimes rock detachment can cause very detrimental way of disaster. We'll see a case study where in Mumbai Pune Expressway in 2015, suddenly in July August, two times heavy rockfall happened and four to five people died. Okay, so the India, which was ignoring the rockfall mitigation measures, all on a sudden became very cautious because humans are losing their life. That is a serious concern. So a caudal formulation has come before that itself. That is in Special Report 23, State of the Art Design and Construction of Rockfall Mitigation Measures. This is published by IRC Highway Research Board, New Delhi. And here you can see a very big chart. Okay, no need to worry, it is all simple. Okay, so rockfall mitigation measures. The first type is rockfall warning measures. So what do you mean by rockfall warning measures? If a rockfall is going to happen, the specialist who is monitoring the stretches, they will be able to immediately take some precautionary measures so that a disaster will not happening in that area. So that is rockfall warning measures. As far as I know, a organization which has implemented it in a very nice way is Kongan Railway. So in 2004, 2005, 2003, and 2004, a lot of landslips happened in Kongan Railway. But by 2004, they found a special type of warning system, which is called a Kacha Daga. Okay. So this was like a digitally, it was getting operated. So at different points, nodal points, wherever slide can happen or rock movements can happen. So one end will be there, and the other end of the sensor, that will be with the engine room. Maybe the engine driver will be able to notice, or a quality supervisor will be able to note it. So whenever a rock is moving and it is going to the detachment level, this digital warning system will work. So Kongan Railway, the senior officials mentioned that they were able to reduce a lot of risk by adopting this type of warning measures. Second is rockfall protection measures. Which are the rockfall protection measures? If in the slope itself we can provide more beams and benches, that will prevent a sudden rockfall. Another is drapery system. What do you mean by drapery system? എന്താണ് drapery system? നമ്മൾ എന്തെങ്കിലും ഇപ്പോൾ സ്റ്റീൽ മെഷോ അല്ലെങ്കിൽ ബയോ എഞ്ചിനീയറിംഗ് മാറ്റോ പോളിപ്രൊപ്പിലിൻ മാറ്റോ അല്ലെങ്കിൽ കൊയറോ ഏതെങ്കിലും നമ്മൾ സ്പ്രെഡ് ചെയ്ത് റോൾ ചെയ്ത് സ്പ്രെഡ് ചെയ്ത് കംപ്ലീറ്റ് ആയിട്ട് കവർ ചെയ്യുകയാണെങ്കിൽ അതിനെയാണ് ഡ്രേപ്പറി സിസ്റ്റം എന്ന് പറയുന്നത്. അപ്പം ഡ്രേപ്പറി സിസ്റ്റം ഇപ്പം ഇത് ഇഫ് ഇറ്റ് ഈസ് എ സോയിൽ സ്ലോപ്പ് ആണെങ്കിൽ നമുക്കൊരു ഇറോഷൻ കൺട്രോൾ മാറ്റ്, ഒരു കൊയർ മാറ്റ്, അല്ലെങ്കിൽ ഒരു പോളിപ്രൊപ്പിലിൻ മാറ്റ്, അല്ലെങ്കിൽ പോളിപ്രൊപ്പിലിൻ മാറ്റിൽ ഒരു സ്റ്റീൽ മെഷീൻ കൂടിയത് ഇത് നമ്മൾ കവർ ചെയ്യുകയാണെങ്കിൽ, ഇഫ് യു ആർ കവറിങ് ഇറ്റ്, the top soil will not be lost and the vegetation will be getting some, if it is coir or jute, that itself can add the nutritive value of the soil, and it can come. Now ഇത് സോയിൽ ആണെങ്കിലത്തെ സ്ഥിതി. ഇഫ് ഇറ്റ് ഈസ് റോക്ക്, ഇഫ് ഇറ്റ് ഈസ് എ റോക്കി സ്ട്രാറ്റ, നമ്മൾ വെറുതെ എവിടെ കൊണ്ട് അതിന് മുകളിൽ കൊയർ മാറ്റിട്ടാലോ അല്ലെങ്കിൽ പോളിപ്രൊപ്പിലിൻ മാറ്റിട്ടാലോ അത് ശരിയാകും. We may have to go for steel meshes, steel grids, high energy absorption panels. പിന്നെ സ്റ്റീലും കൊണ്ടുള്ള ഹയർ സ്ട്രെങ്തിലുള്ള മെഷസും ഗ്രിഡ്സും ഒക്കെയാണ് അവിടെ പറ്റുന്നത്. അപ്പം അത് ചെയ്യുമ്പോഴത്തേനും, അതിങ്ങനെ ഡ്രേപ്പർ ചെയ്യുമ്പോഴത്തേനും അതൊരു ഒരു ഡീപ്പ് സ്റ്റെബിലിറ്റി മെത്തേഡ് അല്ല. ഇറ്റ് ഈസ് എ സർഫഷ്യൽ സ്റ്റെബിലിറ്റി മെത്തേഡ്. ബട്ട് സ്റ്റിൽ അത് പാറയ്ക്കകത്തുനിന്ന് സബ്സർഫസ് വാട്ടറോ സീപേജോ ഒക്കെ ഉണ്ടാകുമ്പോഴത്തേനും, അല്ലെങ്കിൽ അതിനകത്തുനിന്നുള്ള ഒരു ഫോഴ്സ് വരുമ്പോഴത്തേനും, ഈ drapery system, it will hold the rocks together and it will act against the centrifugal force which is coming, or the radial force which is coming from the rocks within. Then നമുക്കത് കാണാം. റോക്ക് ഫോൾ ബാരിയേഴ്സ് ആൻഡ് എംബാങ്ക്മെന്റ്സ് ചില സ്ഥലങ്ങളിൽ നമുക്ക് ഈ പറഞ്ഞ കംപ്ലീറ്റ് ഡ്രേപ്പറി സിസ്റ്റം ഇട്ടും കംപ്ലീറ്റ് ഈ ഹില്ലിനെ മൂടാനൊന്നും പറ്റത്തില്ല. അങ്ങനെയുള്ള സ്ഥലങ്ങളിൽ നമുക്ക് ബാരിയേഴ്സ് അല്ലെങ്കിൽ ഫെൻസസ് ക്രിയേറ്റ് ചെയ്യാം. എന്നിട്ട് ആ ബാരിയേഴ്സിനെ എഞ്ചിനീയറിംഗ് മെക്കാനിക്സ് ഉപയോഗിച്ച് ഡിസൈൻ ചെയ്യണം. ഓക്കെ, എത്ര എനർജി വേണ്ടി വരും? ഇപ്പോൾ ഒരു റോക്ക് ഫ്രാഗ്മെന്റ് വരുമോ, വലിയൊരു റോക്ക് വന്ന് വീഴുക, അപ്പോൾ അതിൻ്റെ നമുക്ക് വെലോസിറ്റി അറിയാമെങ്കിൽ, അല്ലെങ്കിൽ പ്രൊജക്റ്റൈൽ മോഷൻ അറിയാമെങ്കിൽ, നമുക്ക് വി ക്യാൻ ഫൈൻഡ് ഔട്ട് വിത്ത് ഹൗ മച്ച് പൊട്ടൻഷ്യൽ എനർജി ഇറ്റ് വാസ് there, and once it is detaching and moving, how much kinetic energy it is carrying, and what will be the final energy when it is hitting the barrier. Okay, and if the barrier can be designed in an effective way, it can be used a number of times. Okay, so then there are other type of systems also. I'm not going to so much, so that it will be really all on a sudden overdose for you. Then there are rockfall retention measures. Some of our retaining walls, and they themselves can be act as a rockfall mitigation measure. And finally, rockfall prevention measures. Okay, so what I was talking so far, അതെല്ലാം റോക്ക്ഫോളിനെ പ്രിവെന്റ് ചെയ്യത്തില്ല, എല്ലാം ഡിറ്റാച്ച് ചെയ്ത് കഴിഞ്ഞത്തെ കാര്യമാണ് പറയുന്നത്. ഓക്കെ, അത് ഒരുമിച്ച് വെക്കാം, ഡ്രേപ്പറി സിസ്റ്റം വെക്കാം, അല്ലെങ്കിൽ ബാരിയേഴ്സ് വെക്കാം എന്നൊക്കെ. ഇനി പ്രിവെൻഷൻ എന്താണ്? പ്രിവെൻഷൻ എന്ന് പറഞ്ഞാൽ റോക്ക് മൂവ്മെന്റ് ഉണ്ടാകുന്നതിനെ തന്നെ നമ്മൾ അത് സ്റ്റോപ്പ് ചെയ്യുക, അല്ലെങ്കിൽ അതിനെ പ്രിവെന്റ് ചെയ്യുക, അല്ലെങ്കിൽ റിട്ടാർഡ് ചെയ്യുക. അതാണ് റോക്ക്ഫോൾ പ്രിവെൻഷൻ മെഷേഴ്സ്. ഇതിനകത്ത് ഒരു കാര്യം, ഞാൻ ആദ്യം പറഞ്ഞ പോലെ ഒരു പ്രധാന വില്ലൻ ഈ പറഞ്ഞ ലാൻഡ് സ്ലൈഡ് ഉണ്ടാകുന്നിടത്ത് അത് വാട്ടറാണ്. അപ്പം വാട്ടറിനെ നമുക്ക് ഡ്രെയിനേജ് നന്നായിട്ട് കൊടുക്കുക, അല്ലെങ്കിൽ വാട്ടറിനെ ഡീചാനലൈസ് ചെയ്യുക, ഇതൊക്കെ ഒരു പ്രിവെന്റീവ് മെഷറാണ്. രണ്ടാമത്തത് ഡീപ് നെയിലിംഗ്. ഓക്കെ, ചെറിയ നെയിൽസ് ഡ്രേപ്പറി സിസ്റ്റത്തിനെയൊക്കെ കൊടുത്ത് ചെയ്താൽ നമുക്ക് സർഫഷ്യൽ സ്റ്റെബിലിറ്റിയെ ഇത് മാനേജ് ചെയ്യാം. ബട്ട് ഡീപ് നെയിലിംഗ് വിൽ പ്രിവെന്റ് ദ ഗ്ലോബൽ ഇൻസ്റ്റെബിലിറ്റീസ്. So rockfall mitigation measures, ഈ IRC HRB സ്പെഷ്യൽ റിപ്പോർട്ട് 23 കൺവെൻഷണൽ മെത്തേഡ്സ് എല്ലാം തന്നെ പറയുന്നുണ്ട്. അതിനകത്ത് വരുന്നതാണ് ഇങ്ങനെ ഫെൻസിങ്ങും വാർണിംഗ് സിഗ്നൽസും അങ്ങനത്തെ കാര്യങ്ങളൊക്കെ, അല്ലെങ്കിൽ ബേംസ് ഓർ ബെഞ്ചിങ്, ഇതൊക്കെ ഇത് വരുന്നത്. അപ്പം നമ്മൾ കൂടുതൽ ബേംസ് ഒക്കെ ഇങ്ങനെ കൊടുക്കുകയാണെന്നുണ്ടെങ്കിൽ ദാറ്റ് വിൽ റിട്ടാർഡ് ദ rockfall പോസിബിലിറ്റീസ്. സോ ഐ ടോക്ഡ് അബൌട്ട് ബാരിയേഴ്സ്. ഉണ്ടോ, ബാരിയർ ഡിസൈൻ ചെയ്യുമ്പോഴത്തേനും അതിനകത്ത് ഓരോ കമ്പോണന്റും ഡിസൈൻ ചെയ്യണം. ഇപ്പം മുകളിൽ നിൽക്കുന്ന ബാരിയറിന് ഇവിടെ നിന്ന് ഒരു റോക്ക് വന്ന് ഇങ്ങനെ, അപ്പൊ അതിന്റെ പ്രൊജക്റ്റൈൽ എങ്ങനെ ആയിരിക്കും ഇവിടെ നിന്നുള്ള ഒരു റോക്ക് ഡിറ്റാച്ച് ചെയ്ത് ഇങ്ങനെ വീഴുന്നതെന്ന് നമ്മൾ എങ്ങനെ ഡിസൈഡ് ചെയ്യുന്നു? അപ്പൊ എല്ലാത്തിനും സോഫ്റ്റ്വെയർ അല്ലേ? സോ ഗൂഗിൾ ചെയ്താൽ ചിലപ്പോൾ നിങ്ങൾക്കും കിട്ടും. ദർ ഇസ് എ സോഫ്റ്റ്വെയർ കോൾഡ് rockfall which is designed to, അത് ഡിസൈൻ ചെയ്തിരിക്കുന്നത് തന്നെ നമുക്ക് ഏത് തരത്തിലായിരിക്കും ഒരു റോക്കിന്റെ, ഒരു ഡിറ്റാച്ച് ചെയ്തിരിക്കുന്ന ഒരു റോക്കിന്റെ, അല്ലെങ്കിൽ പകുതി ഡിറ്റാച്ച് ചെയ്തിരിക്കുന്ന ഒരു റോക്കിന്റെ അതിന്റെ സ്ഥാനം കൊണ്ട്, അതിന്റെ സൈസ് കൊണ്ട്, അതൊക്കെ ഒരു പ്രൊജക്റ്റൈൽ മോഷൻ നമുക്ക് ചിന്തിക്കാൻ പറ്റും. ഓക്കെ, ആൻഡ് ഇഫ് വി ആർ ഗിവിംഗ് ദ കറക്റ്റ് ഡേറ്റ ടു ദിസ് സോഫ്റ്റ്വെയർ, ദ സോഫ്റ്റ്വെയർ വിൽ ടെൽ ദാറ്റ് ദ റോക്ക് ഈസ് ഗോയിങ് ടു ഗോ ഇൻ ദിസ് പ്രൊഫൈൽ. അപ്പൊ അതിനനുസരിച്ച് പിന്നെ എനർജി കാൽക്കുലേഷനും, ഇപ്പൊ അത് ഓൾറെഡി റോക്ക് സ്റ്റാർട്ട് ചെയ്തു എന്ന് നമ്മൾ ഇമാജിൻ ചെയ്യുകയാണെങ്കിൽ അതിന്റെ വെലോസിറ്റി കണ്ടുപിടിച്ചിട്ട് ഹാഫ് mv², അല്ലെ? കൈനറ്റിക് എനർജി എന്ന് പറഞ്ഞാൽ ഹാഫ് mv², പൊട്ടൻഷ്യൽ എനർജി mgh. ഓക്കെ, ഇതിൽ ഏത് ഡേറ്റ ആണ് അവൈലബിൾ എങ്കിൽ അത് വെച്ച് പൊട്ടൻഷ്യൽ എനർജിയോ കൈനറ്റിക് എനർജിയോ കണ്ടുപിടിച്ചിട്ട് അതിനനുസരിച്ച് ബാരിയർ ഉണ്ടാക്കിയിരിക്കുന്ന പലതരത്തിലുള്ള മെഷ്. ഓക്കെ, അപ്പം ഈ താഴത്തെ ഫോട്ടോ, ദിസ് ഫോട്ടോ ഈസ് is showing a barrier, and this barrier is designed for the energy which can hold the rock. Now for the drapery system, again the design is there. It can be the static energy or the dynamic energy. So the static energy will be coming when we are having the drapery system. The rocks will be moving and the rocks will be getting collected at the bottom of the drapery system if we are putting some anchors or nails. The nail points will collect a lot of rocks, and the rocks together will exert a force or energy in the rockfall drapery system. Okay, and if we are not designing the meshes for holding this uh, static force, then that can cause rupture there. So now for the drapery systems, the different types of drapery systems are there. The drapery system which is connected at top and bottom, the drapery systems which is connected only at the top, and the drapery systems which is connected not only at top and bottom but at intermediate points also. So this all depends on the type of the rock slope and what is the detachment level or the fissures or joints or the faults and faults. So that type of a deep study is there. So by this time you may be having clarity that the rock types, if one has to analyze this, we may have to take the help of a geologist. Now, I really wish to give a small 2 minutes break. But before that, let me talk about one more type of structures before we are moving out from this rockfall type of uh, rock instability. That is rockfall embankments. If we are not having the type of drapery systems or rockfall barriers and all, we can go with the even with the soil embankments we can create, and that can prevent the rockfall. Okay, so this is not in fact correcting the rockfall, the correcting the slope instability. So this is a passive method. Okay, so we are creating a embankment in the path of rockfall. So this is the rockfall. If I am creating a embankment here, that will prevent the uh, disasters which can happen with the rockfall. Then there is one more type of a passive measure is there. This is called a rockfall attenuators or hybrid barriers. So here the barrier will be there, but it is combined with a drapery system also. So a barrier and a combined drapery system. So whatever the rocks which is getting detached from here, that will be interrupted by this barrier here. But suppose if the barrier is getting disturbed or barrier is getting ruptured, still the rock will not jump and create a problem for a running vehicle or a passenger or a someone who is walking through the road, because the even if it is getting ruptured, definitely it will be designed for not getting ruptured, but even if it is getting ruptured, still this mesh will guide it and it will fall right below. So I'm little skipping here. Now coming to the deep, the rock instability, there we have to go for deep nails or deep anchors, and the diameter of the anchors or nails and the spacing between the nails or anchors, that need to be designed based on the soil mechanics and engineering mechanics and rock mechanics principles. So these are some of the structures where deep nailings are decided. Okay, so Mumbai Pune Express, and with all the drapery system, deep nails, which will be preventing the global stability as well as the superficial stability, that was done. And apart from that, a lot of drainage measures, subsurface drainage measures are being provided. So this rock slope at present, it is stable, but it is a combination of the nails and the surface protection drapery system and the horizontal drains. So we were the subject was mentioned as sustainable, innovative solutions, green solutions, right? So what was the conventional system in Mumbai and Pune and all? A lot of shotcreting was there as the system which was preventing the rockfall and all. But this shotcreting, after some time, when the pore water pressure is increasing, the shotcrete used to come out because the shotcrete will not be allowing the water to go. When the drainage is not proper, that is causing further problem. So whereas these solutions, which are really not preventing any for water, not preventing any water flow, it is allowing the water. It is not causing any hindrance or any visual uh, disaster. It is completely transparent, so it can be the rock as such. It will be visible, and the further we can see that also any deterioration is going to happen there. So I talked about the barriers. Barriers also something which is preventing the in a passive way. The if the slope instabilities are there, rock slope instabilities are there, the barriers will collect the materials, especially for debris flow. There are special debris flow barriers are there which can collect all the debris, and that way the disaster will be prevented. Now, some emergency measures. This is also very much required, especially in hilly terrains where a lot of repeated calamities are happening. Okay, in our places like Munnar or Idiki or Nedungandam and all, every year after the flood times, if suddenly some measures may have to be adopted. Okay, but in places in Himalayan states, the quantum of disaster happens, that may recur immediate, like within 2 to 3 weeks. If we are not able to restore the traffic and all, that may be creating a lot of social issues, because many times some villages will be there which maybe only one road will be there which will be going to the school or hospital or anything. So in between a slide is happening and the complete traffic is prevented, then that is really causing a lot of social inconveniences. So we may have to create a retaining system or a preventive system very quickly. So this is a new type of um, product which is mentioned as umbrella system in our the highway guidelines. And the one system which is called AirDogs, that is combining a nail and a barrier system. So we can see a barrier system and a nail together. So this AirDogs, we can see that this rod where a slide has happened, and this was a rod where we have to immediately restore the traffic, and there this AirDog system is being used, and it was able to immediately protect and re-establish the traffic. So the once it is being placed, this close-up shows that the barrier is there and the nail is going inside the soil strata. So if you want to protect sometimes the road tunnels or railway tunnels, the side face, the tunnel portal protection, there also we can go for, instead of going for conventional system, we can go for reinforced soil systems, or in our umbrella systems we can use. So in all these systems we are really avoiding the conventional type of the concrete or the even the steel, whatever we are using are very uh, mild steel with a very small diameter, but having certain big strength, and all these systems can accommodate a lot of vegetation. You may be seeing that even this tunnel portal, it's whatever the stabilization systems which is being provided, with that the vegetation is also one of the component. So why the vegetation will be enhancing the erosion protection, and also its roots will go and apart from the erosion protection, the superficial erosion protection, it will further stabilize the slope, and it will never prevent the drainages, so that it can really going as a sustainable solution. And I don't know whether you all are aware of about carbon footprint. So carbon footprint is something which is a very important concept. The when we are using more green solution or eco-friendly solution, we are reducing the carbon emissions in the atmosphere. Or when we are using the conventional type of concreting, or maybe the stone quarrying, or a lot of transport system has to be employed where from distant places we are bringing the construction materials, that all will be causing a lot of carbon emission. But the different types of systems, whichever I am talking here, the maximum we can use the local materials. Only few materials we have to bring from maybe a factory produced material and all. So just the time is not enough. If it was a workshop, I can very well explain that in a normal situation, if you are using a conventional system, how much will be the carbon emission, and in this system, how much carbon emission can be reduced, and even the techno commercial other comparison also could have presented. But just within 1.5 hours, I will not be able to touch everything. Now, one more that is the even our river banks or seashore. There also a number of slope stability issues are there, especially in the Kerala. The two floods happened. Maximum our river banks got eroded, or it has slipped. So when we talk about the solution for the riverbanks or the coastal environment, there also it is important to understand that what is the type of soil. It can be a red soil like this, which is a vertical cut, or it can be more flatter but very erodible type of soil. So normally, if it is the grain size is higher, it will be more erodible, sand or silt. If it is clay, the erosion may not be that much higher, but there is every possibility of breaching or washing out, or a complete rotational stability issue also can be there. And when we go for the slope stability in a river bank, we were talking so far about the retaining wall, and then the giving some barriers or nailing, or um, uh, the drapery system. These were what we were talking in the previous sessions. Here, when we talk about the in a river bank or a seashore, there we have to consider the hydraulic forces. What are the hydraulic forces which can act? One is the erosive force or the tractive shear force. Okay, the one which is causing the erosion of the soil in the river bank. Second is it will be having a lot of impact force, and the third is the abrasive force. If the water which is flowing, if it carries shingles or soil particle, it can abrade the river bank. So whatever the protection we are giving in the river bank, that should be strong against abrasion, against the impact of stone hitting, against the impact of the water velocity. And if it is a seashore, we may have to think about the cyclic forces like waves, winds, and all. Okay, so some of the protection methods we can see that. See here in this case, it is a Gabion mattress. I talked about the steel wire mesh. the steel wire mesh mattress filled with stones that can be placed in the river bank. And these steel wire mesh mattress can be designed as per the hydraulic velocity of the water and the tractive shear force, which is the erosive forces which is coming. When it is this is in fact a sea shore where rocky outcrops and hills are there. In those type of cases, we may have to think about the hydraulic forces which are coming from the coastal the different types of forces, as well as for the hills, whatever we talked in our first sessions, like rocks, landslide or rockfall, the combined type of calamities can happen here. So we may have to, apart from the regular slope stability forces and the hydraulic forces, here we may have to think about how we can break the water energy. So the different methods like breakwater or groins may have to be provided. Okay, what is breakwater? If we are creating a heavy gravity structure, then if the waves or the water flow is having a lot of energy, that will get dissipated. So, before we are going to the case study session, I would like to introduce certain other building blocks. I introduced the Gabions, reinforced soil systems. Then we talked about the debris flow barriers, steel barriers, drapery system. So another way of systems which can be used for protection of slopes is geocontainers. It is using the polymeric products, we can create big geotextile tubes or bags. So you might be already heard about the geotextile. Geotextile is polymeric products, and using that, like നമ്മുടെ വലിയ ട്യൂബ് അല്ലെങ്കിൽ വലിയൊരു ചാക്ക്, അതിനകത്ത് സോയിൽ നിറയ്ക്കുക. ജിയോടെക്സ്റ്റൈൽ ബാഗ്സ് can be small, which is having dimensions like 1 meter by say 0.75 meter, that type of dimensions. Whereas geotextile tubes, it can have 20 meter or 30 meter or 50 meter. So such type of tubes, if you're filling with the same local material, dredged sand from the same place, that can act as a big retaining wall or a protection for the riverbank slope or the coastal slope. But definitely a lot of engineering factors are there. We cannot use any type of polymeric products. We have to find out the correct specification, the correct GSM, the abrasion resistance, the ultraviolet degradation possibility should not be there. So a lot of engineering properties are there, which is a good news for the civil engineers, because civil engineers will be required to decide all these parameters when the modern world is using all these type of materials. So different types of geotextile bags and tubes, they can be used for shore protection as well as for riverbank protection, as breakwaters, as groins, as longitudinal protection, or even in rivers, check dams and weirs can be made using these type of materials. There are a lot of standards. I can share this presentation to the people who are interested to know about the codes and guidelines which are talking about these type of materials. Many of these, the Indian codes as well as the ISO, I was also a part of the authoring group. So if you are having any type of doubts are there, I can definitely, I will try to help you from my limited knowledge. Now I am, before our time is finishing, I would like to show some of the case studies. This is in Mumbai-Pune Expressway. There for the Valley side, a lot of retaining walls has to be done. So instead of going for RCC walls, RCC was the first decision, reinforced concrete wall. Instead of that, Gabion walls are being used. The advantage was that here a lot of tunnels had to be made. So whatever for the tunnel, they had to do a lot of excavation. So the rocks which has come from the tunnels, that was being used to fill the gibbon box. So the instead of the tunnel muck, which is going as a waste, that is being used as the construction of the given wall. So they have saved a lot of money, and you can see that the gibbons are completely getting covered with the vegetation. So because it is allowing the vegetation to grow. So if it was a rigid concrete wall or a stone masonry wall, this vegetation would have been caused a lot of cracks. So this is a Kerala project, same way given wall. This is in NH47. So you maybe in Sanasi hearing a lot about this Kudiran, there the tunnel and all. So this is in that area. It was an emergency work within 10 days they had to do that. So this is again one of the attraction of this type of technology. You can do it in DP Road, Nasik. Again, this is a black cotton soil which is having soiling characteristics. So usually a normal type of structures, if you are going for concrete structure and all in a black cotton soil, it will generate a lot of cracks. But when we go for this type of flexible structures, that can accommodate the selling or settlement to a great extent. It also will be having its own limits, but it can accommodate a lot of differential settlements and swelling. This is again a structure in slope stability in Kerala. This is one of the first reinforced soil system in this country. It is for Southern Railway, Trivandrum. So we are seeing only the fascia, but a reinforced soil system, a mesh, steel mesh is going inside the soil and it is reinforcing that. And the water is the pore water pressure will be released through the porous gabions. This is a structure in Uttarakhand. It is for the deep landslide prone area, which is called Birahi. What you are seeing is it is in fact a 25-meter high reinforced soil system. The one with the bottom two blocks are with the gabion fascia, and the reinforcement geogrid is going inside. So it is coming almost 15 meter. The next 10 meter, what you are seeing, there also the geogrid is going inside and reinforcing the soil, but the front fascia is completely with the vegetation. Okay, so a 25-meter high wall is managed mostly by vegetation and then the local soil. Whereas if you are going for a counterfort retaining wall or a concrete retaining wall, it will be huge quantum of concrete and steel had to be used. Another structure, this is NH21 in Himachal Pradesh, again a reinforced soil system. This is a rockfall protection system for BRO border roads in OKSRT road in Arunachal. This is again Mumbai-Pune Expressway. You can see the drapery systems, and I already explained that lot of subsurface drainage measures. And this is very near to the Adoshi tunnel. This is where 4 people killed in 2015 monsoon rockfall. Another structure, this is Saptashungi temple. Above that, a rock slope is there, almost 200 meter, which is vertical, and rock detachments were there. So a high strength barriers were installed. And this was installed using, in fact, first time using the helicopter in India. And it is preventing the temple. Otherwise, big damages were happening during the months of July and June. Another structure I talked about air dogs in between umbrella system. So this is a place in Arunachal Pradesh where the avalanches and rock slides are very common. So there this type of umbrella system was used. Umbrella system, you may be remembering, where barrier and nails are combined. And this is again Kedarnath, Uttarakhand, where avalanche protection systems are being used by a series of air dogs. It's all umbrella systems. The advantage of umbrella system is it is lightweight. So definitely the insulation and the foundation requirements are minimum. I'm skipping a little. This is for PHDC, again a rockfall protection systems, where high energy absorption barriers and steel grids are used as the drapery system. So Mumbai-Pune Expressway, this case study is also included in my PPT, but I don't think I will be having the time to describe the complete. But what I want to mention that, see, I was just talking very superficially. Yeah, here this system is being used and all, but definitely a lot of engineering is behind that, like starting from the survey, the LIDAR survey, the drone survey, this type of areas we may have to do these type of surveys, topographic and sometimes if it is underwater we have to do bathymetric surveys has to be done. So starting from the surveying, the geotechnical investigation, geological investigation, hydrological investigation, all these are a part. If it is a small project and small calamity, that much we may not be able to do. But for a deep instability problem, all these multi speciality approach has to be there. And for small problems, definitely a experienced civil engineer may be able to give the quick solution with the limited data. But for a complex situation, definitely the multidisciplinary approach need to be there. So the mapping, the visual inspection and mapping is important, but after that, the different type of geological, geophysical and geotechnical investigations are a must. Then only we can spot the right area of the origin of the problem, and accordingly we can find out the solutions. So sometimes during the construction, we may have to make quick safety barriers and all for taking the or considering the safety of the laborers involved. So this is a barrier which is created for the safety of the laborers. So that is also a part of the insulation steps. So the construction activities, we may have to use the different types of installing techniques. So we can see that for the rockfall insulation and all, climbers, and for sometimes for the river slope or the seashore protection, we may have to employ the divers. So special skilled people may be necessary for the insulation of these type of materials. So Mumbai Pune Expressway, that is what you are seeing. So the second is for the Uttarakhand. So in 2013, big flood has happened, and a lot of places. Yeah. So these type of places, whatever we are seeing, so those are the real incidents happened. A lot of people got killed, and the total devastation has happened. Many villages got isolated, got washed away. So in those type of places, the if we start doing the solution, it will be a very huge expenditure, and lot of effort are required. And definitely with the adoption of the flexible type of solutions, we can really reduce the cost, we can make long standing structures, and we can cover more areas to protect also. So here the solution which is adopted, that is a combination of simple drapery system at the hillside, debris flow barriers, then reinforced soil structure at the bottom, the valley side, a river bank protection, because the Mandagini river which is going below, that is the origin of the complete slope instability here. So riverside protection with an apron and a longitudinal wall. So this is the before the protection, and this is after the protection. The vegetation started coming, and slowly it has stabilized the hillside as well as the valley side. So these are the recent photos, and this is the riverside where a gibbon protection wall and an apron is provided. So there are different stretches like this type of flexible and green solutions completely got stabilized, and riverbanks again got protected with the flexible solutions. Okay. So in summary, the civil or geotechnical engineers, not only geotechnical engineers, this will be, as I mentioned, that multidisciplinary approach has to be there. So it is hydraulics, geology, the structural engineering, everything has to work together. And we have a lot of role to play in our hills, shores, and riverbanks. Thank you.
Hello, participants. Is there any questions to Madam? Participants, if you have any queries, please the time to ask. No.
Yeah.
I
So,
think.
yeah. Can I ask the question? Then. So, like any one of you have really seen any slope instability during the last two flood times in Kerala?
No, Madam.
No one.
No.
Or at least I'm sure that maybe you may be seeing this as a little overdose, because I was talking a lot of things and not going to the depth, just mentioning the different aspects. But I'm sure that you all have seen in the newspapers a lot of cases of landslides, slope instabilities in Idiki, in Munnar, even Munnar Engineering College, near to that. Pettimudi, the last year, there was a serious landslide. So even if you have not attended those type of news, as civil engineers, my request is to please open the eyes and ears, and uh, whenever you are seeing that this type of issues are there, and if it is near to your hometown or village, please go and visit. That itself will give a lot of insight. Yeah. No need to
Yes.
think about solutions immediately, but at least the problem analysis, because the problem, like a doctor has to fix by scanning, by examining and thoroughly the patient. The for the engineers also has to understand that the problem, how we have to really focus on the real issues and spot the right causes, and then only we will be able to optimize it. Because for the construction materials also, we know that every year there is a shooting up of the cost, and optimization is the key for the success. The minimum utilization of the materials, the men, and the time. And for that, the problem analysis is a big part. If we are doing the problem analysis, then only we can do the optimization. When we are not sure that what is the problem, we will not be able to do that. So that is a piece of suggestion from my side. Thank you all.
Okay. Thank you. Ma'am, I think I have one question to ask. Ma'am, my doubt is, and at the end you have shown many case studies.
Yeah.
So, it in the same area, after the successful implementation of these green solutions, sustainable solutions. So, if how far the problem of slope landslide or the problem of landslides have been able to eradicate, or in the next time
Yeah.
when the same condition arises, so if it is, it how effective was the construction?
Okay. So in all the solutions, whatever I have shown, those are so far in the same place. It is successful. There is no repeated failure happened. Okay. But we need to understand that these are all, most of these solutions, whatever I have shown, those are mitigation. Those are not completely, many of it are not completely eliminating the cause of destabilization. Okay. So if the a big force is coming, okay, tomorrow, like in Kongan Railway, a lot of rockfall netting is placed. And what Kongan Railway is, as per their report, 99.5 percentage their accident got reduced after the nettings are placed. But that
Okay,
is
okay.
okay. So up to 2004, a lot of accidents were there. In 2004, people were killed in Kongan Railway. So from 2004, 2005, 2006, Kongan Railway did a lot of measures to prevent the further landslides and rockfalls and all. Not only this type of flexible systems, they adopted different system. They adopted some shortcreting somewhere, but they as per their report, the flexible systems, whatever it was adopted, it was totally, it was a success, and more than 99% it was. And this 1% where they are telling that yes, there is that also, it was not any failure or anything. It was like some slippage or some movements was there, and the mesh was little deformed. Okay, but it was protected, it is still protecting. Then Mumbai Pune Expressway, initially they have in 2001 and all, they have adopted different types of knittings and some shortcreting and all. The knitting they adopted was not, in fact, a engineered system. They just adopted some local type of system without really designing it. So that has failed. Okay. So definitely engineering need to be there. And according to me, it is a good news for the civil engineers that once an engineered system is adopted, it is getting protected. And
Okay, ma'am. So if we already know a region is prone to such a failure, so we can definitely construct it in before this
yes,
failure. Okay,
exactly, exactly. Yeah. So
okay.
if you
At the
are
time
saying
of
that,
construction itself. Okay, okay.
yes, yes. See, if there is a disaster management committee is there for the highway, uh, it's uh, um, it's G6, okay, G6, and there is H10 is there, Hill Road Manual Committee. So they are defining the approach of civil engineers, the pre-disaster approach, the emergency approach, and post-disaster approach. In the pre-disaster approach, it is a lot of prediction and forecasting based on the geology and the geotechnical and hydraulic features, the prediction, and according to that, the measures need to be adopted. Emergency is something, it is happening, okay, all on a sudden something need to be done immediately. That time we will not be have the time for detailed design or optimization or anything. What is available, do it. Okay, so the department has
Okay.
to procure the material every year so that the right time immediately the emergency measures can be adopted. That can start with just our gunny bags to higher level of material. Then post disaster, already disaster happened. Okay, once the social disruptions are rectified, then the rebuilding of roads or rebuilding of railway line and all it has to be done. Here definitely more money will be spending. We will be spending once disaster happened. Okay, it was a very good question. Thank you.
Okay, okay. Thank you, ma'am. So I think there are no more questions. So, madam, so on behalf of Civil Engineering Department, Saints College of Engineering, I extend my sincere gratitude for your valuable talk on the topic environmental solutions, sustainable green solutions for slope stability. As we know, this topic is of current significance as we are facing so many natural calamities in our area. So I think, madam, you have explained everything, each and minute details, including the case studies and all. So I extend my sincere gratitude from the Department of Civil Engineering. Thank you, ma'am. Thanks a lot for your valuable talk.
Thanks to all of you. Thanks to the department. Thanks to your HOD, as well as I would especially tell Dr. Susan George, who is my teacher also in Kodamangala Engineering College. So always it's heartening to see that the students and faculty wish to connect with the industry people like us, and we can share something. And as I mentioned, I shall share the PPT for interesting students. You can go through that, and if you are having any uh, questions further, it is there. You can definitely ask me. All right. Thank
Okay,
you
ma'am.
all.
Surely.
As I have
Okay,
to
ma'am.
join
For
another
sure.
meeting, let me exit. Susan
Okay,
teacher,
ma'am.
bye bye. I will connect with you, teacher, separately. Thank you.
Okay, ma'am. Okay, ma'am. Thank you. So, thank you, participants. Thank you.